Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, a good place to start with this one is to figure out what we want and how to get there. Basically to draw a map of where we're going. So what we want is the charge to mass ratio of a particle. And things we're given are, we have the electric field, we have the magnetic field, and we have a radius of circular trajectory. We have a radius. So, the first step is to find an equation that relates some of these variables, or some of these numbers that were given. So the first equation that we have is the equation for the radius, which is r, radius, is equal to mass times velocity divided by charge times magnetic field. So this is the radius in a magnetic field, which is good because what we're given in the problem is when the electric field is shut off, all we're left with is the magnetic field. Okay, so we have R and we have B. This is what we want, and that's in the problem. So let's go ahead and solve for that first. That'll help us see what direction we need to go in. So this equation becomes, well, we can first off get the m and the q alone. I'm going to invert the equation. I'm going to put the q and the m over on this side. To get it by itself, we need to multiply both sides by b and divide both sides by v. To do that, we end up, or after doing that, we end up with r times b, because we had to multiply it to get rid of it on the mq side, divided by v. Now, we want the inverse of this, so we just flip both sides. So now we have q up top, m underneath, and that also flips the other side. These are just algebraic laws. So now we flip this too, so now we have v up top divided by rb. Okay, so now we have the equation for what we want. This is what we're trying to solve for. So we have r, we have b, we need to find v. So we know that in this piece of equipment, for the particle to travel on a straight line, the electric field, the force due to the electric field, F sub E, has to be equal to cancel out the force due to the magnetic field. And we have equations for both of those. The force due to the magnetic field is equal to charge. This is F sub B. Is equal to charge times the magnetic field times the velocity. Now this is typically sine of theta, also it's the velocity sine of theta, but since in this problem we know that the particle is traveling in a straight line, it means that magnetic force and electric force have to be perpendicular to each other. Or they have to be in the same direction, which would make V 100% in the direction, or in the same direction. So we'd have, we'd end up getting sine of theta to be equal to 1, so we don't need to worry about it in this problem. So this is all we need for the force of the magnetic field. The force from the electric field is equal to F sub E simply the charge times the electric field. Now, we summarized earlier that these two forces are equal to each other, so we can rewrite these equations as Q BV is equal to QE. And since this is all regarding the same particle, it's going to have the same charge, so these two Q's are equal to each other, so we can cancel them out. Now we are given both E and B, so all we have to do is solve for V. And that gives us V is equal to E divided by B. So now we have our velocity. Let's go back and see if we need anything else. So to get our charge to mass ratio, we need to get velocity divided by radius times the magnetic field. We have R, we have B, and we just solved for V. So now all we have to do is plug in all the numbers we're given, and you'll get your answer here. And you want to leave it in this form because it's asking for charge per mass. So those will be in units of charges in coulombs. Mass is in kilograms, the SI units. Another thing to keep in mind, when you're putting in the value for the radius, it is given in centimeters. So you do need to convert that to meters to keep everything in SI units. And there you have it.